our reciprocal identities to graph secant and cosecant. I know that if I've got secant of x, that's just equal to 1 over the cosine of x. Okay? Actually, I want to write these over here. So I'm going to write functions up there. So secant of x is 1 over cosine of x. And then for cosecant, that is the same as 1 over sine of x. Okay? So, when we are graphing these functions, right, on a graph, if we think about graphing sine, so let me just graph one period of sine here without any shifts. So 2 pi, pi over 2, pi over 2, and if we go up, down, up, okay, so here is one period of sine. If I think about taking some of these values and taking the reciprocals, well, at, say, this point right here, okay, if we think about on the unit circle, right, that coordinate point at pi over 2 is the point 0, 1, right? I'm not saying this correctly. Hold on. If we think about, I don't want to take the point 0, 1. I want to think about taking the value of cosine, right? So if we just think about taking, say that our x value is pi over 2, right? At that value, the reciprocal, right, the reciprocal value of 1 is still going to be 1. So the cosecant value and the sine value are actually the exact same right here, right? It's actually going to be the exact same value right here as well. What ends up happening, if I think about taking the reciprocal of these values, this function, this cosecant function, is actually going to kind of be a mirror of the sine curve. And it's actually going to have asymptotes wherever the sine curve crosses the midline. Okay?
So just the zeros.
So, yeah, if there aren't any shifts, it would be the zeros, yeah. Okay? So, the cosecant curve ends up kind of, if we think about taking the reciprocals of some of these values, we end up with a curve like this, right? So it's not super important that you can literally take the reciprocals of these points. What is important is that we can graph the sine curve, right? And then we see that the cosecant curve is really closely related to it because the asymptotes of our cosecant curve correspond with the places where the sine curve crosses the midline, and then the minimum values of our cosecant curve are the same as the maximum values of the sine, and then vice versa. The maximum values of the cosecant are the same as the minimum values of sine. So what this ends up meaning in terms of graphing these functions. In order to graph a cosecant curve, we first want to graph the corresponding sine curve, and then just draw in our asymptotes wherever the sine curve crosses the midline, and then draw in the corresponding mids and maxes. Right? For each of our cosecant curves, we're going to draw in the corresponding sine or cosine curve. Okay? So let's do a couple examples here. Let's say that we want to graph. Let's start with an easier one. Let's say cosecant of 2x plus 3. Okay, something like that. To do that, what we want to do is first graph the corresponding sine curve. Okay? For secant, we would graph the corresponding cosine curve. For cosecant, we're going to graph the corresponding sine curve. So the first thing I want to do is just graph y equals sine of 2x plus 3. Well, I've got a b value, so that's going to change my period. So, just like we've been doing, my new period is going to be 2 pi over 2, which would just be pi. So, that means my period is going to go from 0 to pi. I don't have a c value, so I'm not shifting that left or right. So 0 to pi is going to be my whole period. 0 pi. Split that up into fourths. And then I have a d value. So I'm shifting the midline of my curve up 3. So my midline is going to be here. I don't have an a value, so my amplitude is just 1. So from my midline of 3, I'm going down 1 and up 1 to get to my mids and maxes. And then we're just going to sketch the general shape of our sine curve. So I know I start at the midline, go up to the max, back down to the midline, down to the mid, back up to the midline. So this would be what my sine curve looks like. Now, once we have that graph, graphing cosecant is going to be really easy. The places where the sine curve crosses the midline are the places where my asymptotes are going to go. So I'm going to have asymptotes here, here, and here. And then the maxes and mins of the sine curve are where it shares one value with the cosecant curve. So I'm just going to draw in my cosecant curve in between the asymptotes there, and then again draw in my cosecant curve between the asymptotes here. Okay. Questions? All right, let's do a secant example then. Secant, let's do 2 secants of pi over 4x minus 2 A, B, C, and D here. So what this really means is we first want to graph 2 cosine of pi over 4x minus 2 minus 1. Actually, let's make it, yeah, we'll do that. I don't want to make it too tricky. So that, we'll say that pi over 4 has already been factored out. Alright, so I'm graphing this cosine curve. Start at the b value, so look at my period change. So my period is 2 pi over the b value, so 2 pi over 4. So that would be 2 pi times 4 over pi, which would just be 8. So I have a period of 8 here. So normally my period would go from 0 to 8. But I'm shifting right 2. So that means I'm going to add 2 to both my starting and ending points. So really my period is going from 2 to 10. So we can mark those points here. So 2, 5, 6, 7, 10. So I want to find the quarter marks here, so halfway in between 2 and 10, 6. Halfway in between 2 and 6 is 4. Halfway in between 6 and 10 is 8. So now, I want to look at my amplitude and my midline shift. So I'm moving down 1. So my midline is going to be at -1. And my amplitude is 2. So from the midline, I'm going to be going up 2 and down 2 to get to my mids and maxes. So that means my max will be at 1. My min will be at -3. Then I can sketch in my curve. So first looking at cosine. I know cosine starts at the max, comes back down across the midline, then to the min, then back up to the midline, gets the maximum again. So this would be 1 period of cosine, and my asymptotes now for my secant curve will be where that curve crosses the midline. So that'll be here at 8 and 4. Now, for cosine, this isn't going to look nice if we think about just taking pieces of our secant curve now, because this piece will be nicely contained in between these 2 asymptotes. Right? This piece of the curve will be right here. But now, if I think about, all I'm doing is drawing in half of this side like this, and half of this side like this. Okay. What we can do to make it look a little bit nicer is go ahead and extend that out. So I know that my next asymptote is going to be over here at 12. It'll just be this exact distance one more time over here. So that'll just complete over here. Same thing on this side. The rest of this piece will be that exact same distance over here. questions do we have? What's up? It's all right. Do we want to do a few more together, or do we think?
We do one more.
Do we want to do secant or cosecant? Doesn't matter. Plus. All right. How about y equals -4 cosecant of 2x minus pi. Yeah, how about this? -4 cosecant of 2x minus pi. Okay, well, we talked about we need to factor a 2 out here. So first, we would need to write this as -4 cosecant of 2 times x minus pi over 2, right? So now, what we first want to graph is y equals -4 sine of 2 times x minus pi over 2. What's that? So the first thing I want to do is look at my period change. So 2 pi divided by b, my b value is 2. So my period is going to be pi. So normally that would be 0 to pi. But I'm shifting to the right, pi over 2. So I'm going to add pi over 2 to my starting and ending values. So this is going to be pi over 2 to 3 pi over 2. So I come over here, pi over 2 to 3 pi over 2. Halfway between that would be pi.
You really care how much we should put.
No, not really. I'm just trying to be kind of accurate, but no, it doesn't. Doesn't really matter. So then halfway between pi over 2 and pi would be 3 pi over 4. Halfway in between here would be 5 pi over 4. And we have an a value of -4. So from my midline, which is the x-axis in this case, I'm going to be going up 4 and down 4 to get to my mins and maxes. It's a negative value. So that means for sine, I'm still starting at 0, but then I'm going to be going down first, then back up to the midline, then to the max, then to the midline. So this would be one period of my sine curve. Then, to graph cosecant, draw in the asymptotes at every point where that curve crosses the midline. And then sketch in our function in between the asymptotes, sharing 1 point in each part. If you know how to graph sine and cosine, you can definitely graph secant, cosecant. Okay. Questions? Oh yeah, you actually. All right.
Where you want me to go down and do that? I'll talk a lot to it.
I did sign something for
Pretty
Terry.
loves me. Ready pizza.
Yeah.
Okay.
All right. So let's try a couple of these then.
Oh.
Page 589. So it's 83. All right, so the directions for these don't say to graph, but graph these ones as